I'm going to record the answers so that if you want to hear them again, you can, or those people that are waiting to hear them as well, okay? Again, do not treat this as a temperature check where you are today. How much more do you have to do to get yourself ready? It's okay to get 2 out of 10 on this. You only have to make sure you work to get better than 2 out of 10. It's okay. Overall results, 65%. It's about where I would expect. Not terrible. Okay? Let's go through them one at a time. If a wooden block slides down an incline at constant velocity, the force of friction must be equal to, let's draw a picture here. There's the picture. The force of friction, it's sliding down. What's this one? FD, right? Which one of those is it? Force parallel to incline. Is the answer B? Yeah. And many of you got that right. That's good. Would it help if you saw a picture? Likely. Would it help if I said FN and FD? Yeah, it likely would have. Like if I'd label those FN and FD instead of force perpendicular and force parallel, yeah, it likely would have helped, right? But I'm trying to gauge, trying to challenge you a little bit as well. It's okay, as long as you know it. Stop worrying about the number. A box of weight W, I helped you out with this one, right? Which one is it? It's basically W sine theta, and sine of 30 is? So it's 0.5, so it's 0.5. All it is sine 30 is 0.5, so FD is equal to mg sine theta, mg is W, sine W sine 30, or 0.5 W. It's a fancy way of asking you what's the FD, right? That's all it is. An empty wooden crate is slid across the warehouse floor. If the crate were filled, the coefficient of kinetic friction between the crate and the wood floor. We went through this just recently. When? Like, exactly.
I don't remember that.
Really? Did I not write it?
I thought we went over it like a few days ago.
When Ryan made that comment and I had the 0.2 and the 5 over 10, and then I changed the 10 to 5, it's exactly this question.
Oh.
Maybe you should listen. An empty wooden... Okay, so the answer is remain the same. The coefficient always remains the same. The coefficient always remains the same. If the crate were filled, the coefficient of kinetic friction remain the same. That is an example of a friction theory question. An empty wooden crate is slid across the warehouse floor. It's the same one. If the crate were filled, the force of kinetic friction between the crate and the floor. Would the force of friction change? It sure would. It would increase. Why would it increase? Because I filled it. I don't know why. Yeah, there's filled right there. Mu equals FF over Fn. If I fill it, then that means that the Fn becomes bigger. And so the only way for the Fn to get bigger is if the Fw gets bigger. That way the mu value stays the same. The force of friction changes, not the coefficient. A 5 Newton block with a surface area A is dragged across a horizontal wooden table and experiences the force of friction 2. What is the friction force acting on the 5 Newton block when the surface area is increased to 2A? Does it change?
No.
Friction is independent of surface area. I know I said that. Friction is independent of surface area, so the friction force remains the same. Remember me talking about the book? I'm saying the book sliding when it's flat like that is the same as the book sliding like that?
Oh, I remember.
Remember that?
I remember. See, that's what I was afraid, but I couldn't remember what the answer
The force of friction doesn't matter on the surface area. It's the weight that matters. Which pair of quantities can be used to determine the coefficient of friction for granite on concrete? Mass and speed of block?
No.
Mass and normal force on block.
Yeah.
That's kind of the same thing, isn't it?
You don't need it.
Friction force and speed?
No.
Friction force and normal force?
Yes.
Yes. Does it matter that it's granite on concrete? No, it could be titanium on kryptonite. It doesn't matter. It's always the same. Friction and normal force. Mu equals FF over Fn. How we do here? Whoa. Force required to start an object sliding across a uniform horizontal surface is larger than the force required to keep the object sliding at a constant velocity. These forces are different because the force of friction is less than the force of static friction. Kinetic is less than, occasionally equal to. Right? It usually takes more push to get something started. Examples of friction theory. 50 Newton horizontal force is needed to keep an object weighing 500 newtons moving at a constant velocity of 2 meters per second across the horizontal surface. The magnitude of the frictional force acting on the object is, this is a grade 11 concept. We did this over and over and over again. If you need 50 newtons horizontally to keep it moving sideways at a constant speed, right? In other words, if this is 50 newtons and it's moving at a constant speed, what does the friction force have to be? Minus 50, isn't it? I guess the best answer is D. How'd we do? Well, do I expect you to be able to apply knowledge that, yeah, I do. It's what the expectation is. It's not a regurgitation course. 20 Newton block slides over a horizontal table if it takes a force of 5 newtons to move the block at a constant velocity. Hey, isn't this exactly the same question?
No, it's not.
Isn't it?
Oh, yeah, no.
It's exactly the same. It's the same question as 8, isn't it? What's the key words?
5 Newton.
Constant velocity, meaning net force is 0. $20 Newton block slides over a horizontal table. If it takes 5 newtons, what's the coefficient of kinetic friction? Mu equals FF over Fn. So what's the FF? We just found it out. It's 5, isn't it? Over, normal force is 20, 0.25. B. That took longer than I had hoped, but oh well. How do you want to attack the next 15 minutes? Do you want to listen to me do a sample question? Yeah? An equilibrium one?
Yeah,
Do you want to find one for me?
Retention.
Do you want to find one for me? I should be recording this. So we've got 750 newtons of weight force. We got a 30-degree angle. Which cable is holding the sign up? A. What does B do?
Just kind of sits there.
Well,
Takes the ball. If the wind starts blowing, maybe it'll stop.
you don't often see this kind of thing, right?
Oh, it's 0.
No, it's not 0 because A has a, let's call this T. A has a Y component and A has a X component. Which way is that X component? It's pulling it to the left, right? So this X component, is there an acceleration left and right? So the X component is balanced by tension in B. B and TX are playing tug of war and they are equal. How can you tell? Sign's not moving. What if B wasn't there? What would happen to TX? Would it pull it sideways? No, there would be some compression of the sign against the wall, right? Maybe, just maybe, wire B is there because for some reason maybe the sign is very fragile and it can't handle the compression. Or something like that, right? What would happen if you increased the angle of 30? What if I moved my dot? What if I moved it way over there? What would happen? Would it increase the tension? Yep. It sure would, right? The greater that is, right? If it was like that, remember? The flatter it is, the more tension there is. Remember the little demonstration with the strings? Okay, so back to the point at hand because I don't have much time. Okay. Tx, Ty, oh not Tx, sorry, just T. Tx, Ty, right? What does Ty equal? 750 newtons. How do you know? The sign's not going down. There's only one vertical component that's holding the sign up, and that's Ty.
Do we need to find Ty?
No.
We're going to.
Well, it's asking me, I need to find the tension in cable B. So what I really need to find is, this is Tx, right? I really need to find Tx, don't I?
Yeah.
But how do I find Tx? Well, I gotta have a side of that triangle. The only side of that triangle that I know is Ty. So I have to make this connection here, right? Looking at this triangle, this is Ty is 750. This is 30 degrees. I need to find that guy right there, right? Opposite, adjacent. So we're going to use tan. Tan 30 is equal to opposite, Tx over adjacent, Ty. Oh, my Ty is? 750. So Tx is 750, whoops, tan 30.
Is that a divided? What is that?
No, that's tan. I wrote tan.
No, is that?
750 times the tan of 30. Yeah, multiply. $433. Does that seem reasonable to you? What's the tension in cable B? 433. How come? Therefore, B is 433. Technically, this 433 is to the left, and it would be negative, right? B has to balance it. 433. The net force, both vertically and horizontally, Zach, is 0.
Okay, wait, why is Tx negative?
It's to the left.
How do you know? I don't see any arrows.
It's to the left. I can see that it's to the left. I put that in after it. It's not going to come out negative out of here.
Well, yeah, but
That's-
I mean, how do you know there's no way?
No, you just need to know that it's to the left and it's negative.
That's your only force vertical. That's your only vertical tension. So that equals your weight.
This Ty is equal to the weight force. It's the only vertical tension.
There would be like, a lot of questions there's two, so they'd have to be split out.
There could be, yes, that's certainly true, Steve. Steve's saying that a lot of the time the angles are like this, right?
Yeah.
And you have to divide it by 2. What do you do if you got a situation like this? And I know what the next question is going to be as soon as I draw this. What do you do if the situation is like that, where it's not the same angle?
Vector addition.
This Ty and that Ty have to equal together that FW, right? Is that a challenging question?
Yeah.
Oh, yeah.
You're gonna do that on the test?
No.
Oh, you put one on the review, I think.
But there might be one on the review. That would be like above and beyond. That is like, yeah, you know your stuff.
Is that vector addition?
Oh yeah, it's vector addition. It would likely end up with a system of equations, I would think, with 2 equations and 2 unknowns, like a Fred and Marty kind of thing.
Oh.